Hey guys, today we're going to be working on what will be part D of your worksheet, and then also these notes that go along with how to name acids, both binary and ternary acids. An acid is really just a special kind of an ionic bond, and acids are important because they play a very specific role in chemistry and in biological systems. So when an acid is released into water, it produces hydronium ions, or an H+ ion, that then floats in the water, in the liquid, and does specific things to the environment or to the cells or to the other chemicals that are around it. All of that is a really important topic for chapter 19, which we don't even cover until May. So for this chapter, instead of being very concerned about what an acid is or how an acid is behaving, we're just kind of taking the naming or the nomenclature of acids and we're just including it in this chapter where we're learning to name all the other kinds of ionic bonds. So basically, while it's fresh in our mind, we're going to learn how to name acids as well. There are two kinds of acids that we're going to learn to name. The first one is called a binary acid. And so a binary acid, it has two things in it. It is a hydrogen and a halogen or some other anion. So when hydrogen combines with an anion, like a halogen, it's going to form an acid when dissolved in water. So if you bubble this through water, you can create a binary acid. So basically what we're looking at when we look at an acid is just an ionic compound where H+ is the cation. So the cation is H+, and the anion is whatever anion we are looking at. So if we are looking at a specific acid, we name that specific special acid by putting a hydro in front to represent hydrogen. So a hydro in front. And then instead of the normal ending that we have, we remove that normal ending and instead we write ic acid. So I'm going to show you one of those. So where we might call this compound hydrogen bromide according to our names, if I tell you that this is an acid, if I indicate that this has been dissolved in water and has become an acid, instead of calling it hydrogen bromide, I'm going to get rid of the hydrogen and just say hydro. And I'm going to get rid of the "ide" and we're going to call it an ic acid. So the name for this HBr, if I indicate that it's an acid, and I will on the test indicate that it's an acid, is you would call it hydrobromic acid. And so it's really important to make sure that we know that hydro is something that we only do if there is no polyatomic ion. Only used if there is no PAI or polyatomic ion. So we don't use hydro if there is a polyatomic ion in the acid. Let's look at this one. We're looking at HCl. So there is no polyatomic ion here. It's just H and chlorine. So we know that this is an acid. I'm going to tell you in the instructions that it's an acid. And so you see hydro, okay, we represent the hydrogen with hydro, and then we call it hydrochloric acid. Hydrochloric acid. Okay, try this one. HF. Hydrofluoric acid. Hydrofluoric acid. Good job. HBr, that's the one we already did. Hydrobromic acid. Good. And last one, H2S. So even though there's a 2 here, we just ignore that because remember this is an ionic compound. And so there's only one way for it to fit together, and it's that crisscross and reduce balancing of charges thing. So we don't need to represent the H2 at all. So we just call this hydro, and this is the trickiest one, sulfur doesn't become sulfic, even though that's the rule. It should become sulfic, but it doesn't, okay? It's hydrosulfuric acid. It keeps its UR, even though it shouldn't. It's an exception. So hydrosulfuric acid. So those are all of our binary acids. So here come ternary acids. And I'm sorry to tell you that ternary acids have a whole new set of rules, okay? So when we see a ternary acid, first of all, how do we know it's a ternary acid? We can find a polyatomic ion in it. It's not just H and one more thing, it's H and a polyatomic ion. So I'm going to put some examples of what this might look like on my board. These are some different binary and ternary acids. So you can see that in the binary acid, it's always hydrogen and just one more thing. Hydrogen and sulfur, hydrogen and fluorine. That's binary. Ternary acids have within them a polyatomic ion. So it's hydrogen and chlorate, or it's hydrogen and nitrate, or it's hydrogen and phosphate. So when you see a polyatomic ion, you know that it's a ternary acid. So when we're talking about ternary acids, there are polyatomic ions involved. In order to name the ternary acid, we just need to think about what kind of polyatomic ion is it. So if the original polyatomic ion ends with ATE, like phosphate, sulfate, chlorate, nitrate, all of those would just be ic acids. So they would be chloric acid, sulfuric acid, phosphoric acid, nitric acid, no hydro, right? Hydro is only for binary acids. Ternary acids do not get a hydro. And then they are an ic acid. If the polyatomic ion ends in ITE, nitrite, chlorite, sulfite, then they become an us acid, O-U-S, us, sulfurous, phosphorus, nitrous acid. Okay, so a different ending indicates a different polyatomic ion. We have to have these very specific rules because when you're talking about something like Cl minus, right? So that would be hydrochloric acid. But then you also have ClO minus, ClO2 minus, ClO3 minus, and ClO4 minus that can all bond with hydrogen. We need a lot of different names for acids. So the rules are very specific, and we will go over kind of a naming tree to help you guys figure out exactly how to name everything, or to organize all of the rules. But for now, we're just going to try them, and you guys can do this, okay? Take it one bite at a time, and you can do this. Okay, so we're starting with HNO3. So in order to do this one, we start with HNO3, and first we recognize the polyatomic ion. NO3 is nitrate. That tells me that this acid is called nitric acid. If instead I had HNO2, that polyatomic ion is nitrite. And so this acid would be called nitrous acid. So there you have it, two different names for two different compounds. We know these are ternary compounds because they have polyatomic ions, and that's why we know that they're not hydronitric acid. Okay, we wouldn't do that because we have a polyatomic ion here, no hydros. Okay, let's try some more. So when we look at something like H2SO4, we start by recognizing that it's a ternary acid. So we know there's no hydro. Then we look at SO4, and we know that SO4 is sulfate. So we call this acid sulfuric acid. Now if we look at HSO3, we notice that the SO3 is sulfite. So we call this sulfurous, because remember ITE gets the OUS, sulfurous acid. Now we can look at H3PO4. PO4 is phosphate, so we call it, you're getting it, phosphoric acid. CO3, so H2CO3, we know that that's carbonate, so we call it, and this one has a little different emphasis, carbonic acid. Good. This one is the trickiest. This is acetate. Remember acetate, CH3COO-, and that's ATE, so we actually call it acetic acid, and this is the acid that is vinegar. So if you've ever known that vinegar is an acidic flavor or an acidic taste, the acid that is in vinegar is called acetic acid. So don't overthink it, guys. Focus on the polyatomic ion first. So when we look at something like HClO, we know that ClO is hypochlorite. So we call our polyatomic ion, ITE gives me an OUS ending. Hypochlorite becomes hypochlorous acid. HClO2 is chlorite. ITE ending gives me an OUS. So chlorite becomes chlorous acid. ClO3 is chlorate. Chlorate becomes ATE, becomes IC, chlorate becomes chloric acid. And HClO4, ClO4 is perchlorate, so ATE gets an ick, perchloric acid. And guys, if you got all four of those, give yourself a big pat on the back. You are doing a great job. You have mastered acids. When you look at your worksheet, you can now do part D, and you should really easily be able to do 46 through 55. You should be able to do 56 through 60, although with a little bit more difficulty. So included in your homework, when you guys come into class on Thursday, I will answer questions on anything parts A through D. Remember, this whole worksheet is not due until Tuesday, but you don't want to put it off until then. Make sure you can do these sections. So as you start working on it today, definitely get through 46 through 55, and then we will talk about 56 through 60 when I see you guys in class on Thursday. All right, have a great day, you guys, and I'll see you soon.